In a car lift, compressed air exerts a force on a piston with a radius of 4 centimeters. This pressure is transmitted to a second piston with a radius of 12 centimeters. How large of a force must the compressed air exert to lift a 1.5 times 10 to the 4th Newton car? What pressure produces this force? Alright, the first thing we're going to do is write down all of the givens and draw the piston that's actually lifting the car. This first piston has a radius equal to 4 centimeters, and the second piston has a radius equal to 12 centimeters. All right, now this force on the left-hand side is going to be pushing down, and this force is going to be pushing up. You have a small input force for a large output force, a small radius for a large radius on that side. Let's first convert these radii. 4 centimeters, move the decimal over twice. This becomes 0.04 meters. And then the second radius is 12 centimeters. That's going to be 0.12 meters. The area of the first piston is going to be equal to pi r1 squared, which is going to be pi 0.04 squared. And we need to punch that in a calculator real quick. Alright, that gives us 0.0050 meters squared. And the second piston will have an area equal to pi r2 squared. So that's going to be pi times 0.12 squared. 0.12 times 0.12 times pi. And that gives us 0.0452 meters squared. We'll round off just a little bit there. Now, the question is asking, what is the force that the compressed air must use to lift the car that has a weight of 1.5 times 10 to the 4th newtons? According to Pascal's principle, the pressure for area 1 is equal to the pressure on the other side of area 2. This means that the pressure is distributed equally throughout the entire hydraulic device. So pressure 1 equals pressure 2. Pressure is equal to force over area. So F1 over A1 is equal to F2 over A2. We're solving for F1. So F1 is going to be equal to F2 A1 divided by A2. F2 is 1.5 times 10 to the 4th newtons. A1 we determined to be 0.0050. And A2 is going to be 0.0452. And punching this in really quickly. Is 1,659.3 newtons. And that's number 1.